Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software faster and better.
If you're looking to build a test and ship, tune in, let's confidently commit.
I'm Rob Zuber, your host, CTO of CircleCI, and today I'm joined by Nathan Mellis, Head of Engineering from Modzy. Thanks for joining me today, Nathan.
It's my pleasure.
All right. Well, let's jump right into it. I'm super excited about this. I love what you all are doing, and in particular, I think that I'm going to give you a second to tell us a little bit about it. But the whole space of ML and how that ties into how we deliver and sort of what we think about in terms of delivering models versus software. Like, there's just a ton of stuff to unpack and dig into in there. But to kick us off and to sort of give everyone listening a background, can you tell us just briefly what Modzy does and what problem you're trying to solve for your customers?
Yeah, of course. So Modzy was designed to solve the last mile problem for AI. When we talk about just delivering AI in production, we often talk about the AI valley of death, which is this trend that we've seen where like 50% of models never make it into production. And those that do can take like 9 months to get through all the regulatory hurdles, get your infrastructure provision, get your security and IS teams to approve it. And by that point, then you have to like integrate it into all of your systems and pipelines and stuff like that. And it turns out it's just really hard. And we encountered this ourselves, doing work for, a lot of big organizations, government, commercial. We had these awesome, amazing models that were ready to go, but we couldn't get them to a place where users could actually use them. So we built Modzy, which was designed to help data scientists get their models from their laptops into production, and then make it really easy for developers to utilize those models using a simple API-driven approach. So it sort of bridges that gap, and then the security folks like it because they can pre-approve, the platform, and you don't have to go through that whole approval process for every new model.
So I already have so many questions already. I love this subject, but one, I would love for you to just give us maybe a concrete example, like for people to get their head around. Even I'm shipping a model versus I think a lot of people think about shipping software and have sort of got that firm. And then, well, let's start with that. I'll give you my second question once you're done with that.
Sure. Well, one of the so let's talk about deep learning models because those are sort of the most interesting ones. AI is just software, so it's not really any different than any other kind of software, except it doesn't always behave the same way every single time you call it. So if you write a function that takes in a first name and then returns all of the friends that you have or something like that. That's fairly deterministic, kind of a thing. But for AI, not only will the result differ depending on the input that you give, if you give it if you have an image recognition model or an object classification or object detection, you can give it an image and it'll give you one answer, and then you just tweak a few pixels and give it again. It'll give you a completely different answer. You have to sort of like take that into account. So file formats, what kind of compression is on the image, what's the size of the image, how many color channels are there, some models are really, really sensitive to those sorts of things. And so it's not just, like JSON input, JSON output, like you find with most sort of web-based things delivered today. It's you have just binary blobs of data that could be anything. You throw it into this magic box and you get out an answer. But, how do you know if that answer is correct? How do you know if it's behaving well? What happens if someone, gives you the wrong thing? Is there a way to know? So it's all the stuff you have with delivering software normally. But then, because of sort of the nature of artificial intelligence and machine learning, you've got all these other things you have to think about and take into account too, in order for it to be truly useful in production.
Well, you very effectively outlined my next question, so I'm glad I just let you do it. But you mentioned sort of, I don't know if you said it in these words, but deterministic, right? Versus, I imagine most of the models are probabilistic. I think that's so. I personally have spent a lot of time thinking about things like pure functions, right? Which would be the exact opposite, right? So it's not just, you said if I give it a name, it will tell me the list of friends, right? But my list of friends might change today or tomorrow. It's like I give you the name and the list. Tell me which of these are the friends. Like I can test that all day long, and it's always going to give me exactly the same result.
Mm-hmm.
Whereas you're describing, I guess the the functional programmer's nightmare, which is there's this entire model underneath that that's changing and is sort of the exact opposite of provably correct in some regard, and that it's there's new information all the time as it's being updated. So how do you then think about demonstrating that that's correct, right? That it's I don't know if it's good enough to be pushed into production or that it's demonstrably correct. Like how do you actually think about that question of what is good for a model?
Yeah, so I'll freely admit that this is a little bit outside my realm of expertise. I'm a software engineer. I'm not a data scientist. So my knowledge on this is fairly we'll say introductory. But I know for us at Modzy, and as we talk to our customers, as they're trying to wrestle with this problem, and as well as talking with industry analysts, because like the industry's figuring out how do you do that? How do you know when a model is no longer good enough? Oftentimes it's referred to as model drift, and where either it's returning different answers than it used to for similar kinds of data, or the data changes. You may have a model that was trained on, a 720p camera, and all of a sudden you're feeding it 1080 images. So now, it's a lot sharper, and that may cause it to behave differently because it looks different than what it was trained on. And because these are neural networks, you think about it similarly to the way that you would a human brain, just a lot less complex. And, if you walk around, like me, I've worn glasses since I was like 3. If I walk around without my glasses, I'm going to see the world differently. But then you all of a sudden put them on, you can see more details, and it's like, oh, that's not a rock, that's a cat, or whatever. So this is a real problem, and there are lots of people doing a lot of work, both on the research side of things as well as sort of on the commercial and product side of things, to give operators of artificial intelligence the data that they need to decide, like, hey, when do I need to when do I need to do some retraining? When do I need to go get more data? When do I need to retrain my model to have it continue to have that level of effectiveness that's important?
Yeah, It's so fascinating to think about, again, just from a pure deterministic perspective. Like, I think we spend a lot of time trying to be certain that the software we write will execute exactly the same way that we expect every time. And you made the comparison to the human brain. I think we've come to the conclusion generally that a growth mindset is positive, right? All of those additional signals that allow me to have a more nuanced or correct or just advanced interpretation of an outcome, which may be different from what I thought before. Like that's positive and that's good, but you're expecting a particular behavior, I guess, as you're using it. So if we go back a little bit, I mean, you said you're a software developer by background. I guess as you think about the delivery, right? Just the delivery piece, and one thing that we think about a lot is the balance of sort of speed and innovation against risk, maybe that goes into, have I demonstrated that this is correct? How big is the risk if it's wrong? Is that something that you think applies, first of all, in the sort of delivery of model perspective, and then second, is the calculation any different in terms of, how right do I have to be about this, or is it completely, I don't know, business or task dependent?
Well, I think, all of the reasons why you engage in sort of modern DevOps processes for doing modern software delivery, all those still apply to models. I mean, again, models are just software. It's just software that has some magic, aka advanced math, involved. So you still want to know, like, what exactly am I shipping out to production? Can I go back to a source code, commit that represents that? Can I go back to a build log from my CI system to see exactly what was built, what tests were run? did it pass, linting tests? Did it pass, all that kind of stuff? So all that is still true. And the only sort of additional thing for models is you want to know what was the exact training data set that resulted in that weights file or architecture file or algorithm that was developed that you're then shipping. So, so the software is one thing, but for models, it's also about the training data, because that's the thing that, tweaks that model to be good at whatever it's good at. And so you not only have to version your code, you have to version your data if you're training models as well, and have a way to get back at that so that you can reliably reproduce your original training run in case you need to like do forensics or something like that on the model.
Got it. And so I think that's a really interesting and important call out for those of us, and I'll include myself, who don't spend all their day, on models and ML, which is that you are effectively versioning, stamping, whatever the approach is, the training data as well as the model to say, okay, the output of these two things should effectively be deterministic, right? If we then take the same input with this code and this data as the training set, then the output should be consistent. Is that a good summary?
Yeah. So if you have the exact same input on the exact same model, you should get basically the same output. It is a computer after all, and computers are thank goodness, only do what they're told. So it's not thinking for itself. So like the exact same input on the exact same model should result in plus or minus the exact same output, but they're just a lot more sensitive to anything that changes. We've done some research into adversarial defense. So I'm sure we've all heard of the instance where somebody slapped a sticker on a stop sign and a Tesla or some other autonomous vehicle saw it as a 55 mile an hour zone and blew right past it. That's a sort of trivial example of adversarial attacks on AI. In our own research, we've determined that even changing like the shade of 12 pixels randomly dispersed through an image is enough to get it to some models to change what their classification is, which, for, autonomous vehicles, obviously important. But then you get into like the medical industry, difference between a false positive or a false negative. Those are really important. Not to say anything of, sort of more serious applications of AI, that all.
Yeah.
Yeah.
Yeah. Well, I noticed, I think the image and sort of, I'll call it vision, angle is one that's really well understood. I'm sure there are many, many other spaces where you have, large data sets and trying to make observations and decisions based on how they're moving. So one thing that you mentioned early was the, security, compliance, some of these other reasons that you want to feel good about the model that you're putting into a production environment or allowing users to interact with, whatever that looks like. Are there cases where folks are doing more either learning on the model while it's live because new information is coming in, like that's getting added to the data set? Like, is there sort of a different perspective where there's more continuous updates to the training?
Yeah, absolutely. So that's sort of like the most mature stage of running AI in production. But take Facebook for example. They have their facial detection model, that they run on every image that gets uploaded to Facebook, and they're continuously training that model and pushing out updates continuously, to Facebook.com. So, so they're sort of at the extreme end of maturity for this kind of a delivery. I'm sure the same thing could be said of Amazon and Google and all the others that are sort of applying these, these AI processes for, Alexa and, and all that kind of stuff. But, as I said earlier, for most people, the problem is just I got this model, like, how do I use it?
Yeah.
So like the continuous retraining aspect is definitely a thing. But, like the first step is like, you got to use it first and gather that data to know when you need to retrain. And so there's sort of a maturity level as you keep going. So.
Well, I think the analogy, I mean, you keep saying models are just software. I think I'm going to take that away from this for sure. But the analogy to what I'll call more classical software delivery, even though I have no idea what I would call it that, is even stronger than I would have thought, which is, yeah, you start by just writing some code and finding some way to get it into an environment where people can see it and access it and give feedback. And then you tend to get better and better at collecting that feedback and iterating quickly and pushing out new changes, those sorts of things. So it seems like it's much more analogous than I probably would have first thought.
Yeah, I mean, the one of the mantras for modern software delivery is release early, release often, right?
Mm-hmm.
And you can do the same thing with models. You train it, and it's just like, great, this model is really good at detecting dogs, and then you have it try cats. Like, oh, well, it doesn't work. Okay, well, now I got to go find some training data set for cats so I can train it on both. And over time, your model evolves into being able to do more and more things or get more and more accurate as you find more edge cases. We're seeing this particularly in the medical industry where, you have, certain models that are better than the best human on average, at finding certain kinds of cancer on MRIs, for example. Mm-hmm. And that's because as they add more and more data about more and more edge cases, and as we learn more and more about it, you can throw that into the model gets smarter, and then it's able to do that same thing the same way every time, which is what computers are really good at and humans are really bad at, right?
Yeah.
And it doesn't need to sleep. You can feed it, you can scale it 1,000 times or 1,000,000 times and, start to feed all sorts of data through it, which you can't do with humans either.
Well, I mean, I love this whole subject, right? In that, where do we take advantage of machines? What are they good at? And earlier you said, it's a computer. It does exactly what you told it and nothing else, right? So that's an interesting, I mean, when we talk about AI, of course, we all imagine the sci-fi that we've watched where, the machines take over the world or whatever, but we're still talking, at least in this conversation, very much about, I taught it to do a thing. It will do that thing repeatably, reliably, without drinking Red Bull, all the things that computers can do that we can't. So let's tie that back to software development itself. I mean, I think, when I got into this field, we were already talking about neural networks and how everything was going to change. I don't think that happened. That was sort of late 90s, but we're getting there, right? Like we're able to build and understand. We have enough people able to build and understand AI and ML tools. We have the data sets that are large enough to really train them and make them useful and valuable. We have enough photos of dogs on the internet now that we can build that recognition. So I guess I'm curious, as a developer, how much my world is going to shift in your mind over the next 5-10 years. Like, how much of what we do becomes ML versus something else, or does that enable us to go do different things because some specific, maybe things that are repetitive today, shift to the ML world and we go do different things? Like, how are you seeing it? Just because you're sitting at the center of so many companies doing this, how are you seeing the kind of the face of software development change as these tools mature?
That's an interesting question. I don't know that anyone knows the answer to that yet. I mean, my instinct tells me that there are certain things that are going to stay the same. I mean, we write software to solve problems, mm-hmm. right? Or to make life better in some way, and that's not going to change. But I think the thing that is going to surprise us all over the next generation or so is what kinds of problems we try to solve and how we go about doing it. In the past, things that were procedural or algorithmic or involved, computation or some, things like that. Those were great to throw computers at because, they could do it faster than a human could. They could do it more reliably than a human could. And they didn't need to sleep. So we did that. But now that, you have, now there are a lot more options. I think about just even speech recognition. I remember trying my first time using Dragon Naturally Speaking in like the late 90s, early 2000s. It's just like, it blew my mind, even though it only got like 1 out of 12 words I said correct at the time. And, but nowadays, like I go over to my best friend's house and, watch her like, 1.5-year-old having a fluent conversation with Alexa, and Alexa knows exactly what he's saying. And I have no idea what he's saying. So that's pretty incredible, just the quality of speech, and speech recognition and things like that are just a new way of interacting with computers that has been around for a long time, but it's not been particularly accessible. And yet all of us find ourselves, hey, Siri, do this, or, hey, Alexa, do this, or whatever. So I don't know that we know how people are going to solve these kinds of things. In fact, right now, Modzy's running a hackathon, for over the next month or so, because we're interested too to see like, hey, if you make it, really easy for people to use AI, what are they going to do with it? And so I think we're going to be pleasantly surprised at some of the new problems and new solutions that no one's ever thought about before, because the technology is available, it's cost effective, and it's easy to access. So you don't have to go to a big university or have to work for a Fortune 500 company. You can do it in your in your bedroom on your laptop, in your spare time.
Yeah, I think that's a fantastic perspective. I mean, we spend a lot of time, CircleCI, but also everyone we talk to, thinking about how to deliver more value to our customers faster, right? And so framing it in that way and saying, look, like we're building a stack of tools, and that stack is getting broader, it's getting deeper, it's getting more advanced, and therefore we can solve interesting customer problems, either new problems that we could never have solved before, or the same problems much faster because we have a broader toolkit. And I feel like you're correcting the way that I asked the question in a really helpful way, which is, if I think of my job as a software developer as writing lines of code, then, maybe that job is going to change significantly. But if I think of it as bringing to the table a set of tools that I have the skills to combine and the creativity to see the patterns and say, oh, I could solve that problem knowing what I know about this disparate tool set, then I have lots of things I can go do that are going to continue to be really, really interesting and exciting. I mean, my takeaway from that, though, is absolutely see how these, like we talk about, easily available, readily available ML and AI tools, like go take a look at them and see what's available. And hey, could I apply that to this problem over here, this problem over there, sort of thing. Like, joking about late 90s, nobody thinks about building out a data center anymore. Like that was the baseline, right? I got to go.
I don't know.
Space.
Things are changing. It's sort of swinging back
at large enough scale. But no one says, "Hey, we're going to start a company. Let's buy a rack in a colo and go install some boxes, and then we'll start writing code." It's like I can turn that on in 20 minutes, right? As soon as I've got "Hello World" written, I can have it deployed on the public internet.
Yep,
it's that easy, right? So. That's just, this is another thing on top of that stack. Hey, could I do image recognition? Could I do, speech recognition really easily as part of an application I want to build? What does that allow me to do? And it's kind of funny as a consumer, I think we get so accustomed to all these like super powerful capabilities that are on our phones, on our laptops, whatever now. But as builders, developers, however you want to think about it, acknowledging, wait a second, these are things that I can bring to my problem space and grow that, I think is a really interesting, cool thing.
Yeah. Well, I'll never forget. So before joining Modzy, I spent 4 years at Apple working on the iPhone and the iPad. And I started there in 2009. So it was right before the iPad was announced. And so, those of us who were working on it, it was, we were like, I wonder what people are going to do with this thing. Like, obviously, hey, it's great for reading and it's good for, browsing the web. And, but it's like a big iPhone, right? And that was what a lot of people had thought at the beginning. It's like, hey, it's just a big iPhone. Like, how useful is it? But it became pretty clear pretty quickly, once people got their hands on it, just all the crazy, amazing, interesting things that you could do with an iPad that you couldn't do with an iPhone. And we were just blown away with just how creative people were getting, mobile recording studios just on an iPad and, just all sorts of stuff that we're still, I haven't been out for a while, but, still sort of surprised to see just the creativity that people have when they're given a powerful tool and the opportunity to unleash their imagination, what they can come up with. And I think we're going to see that with AI, over the next 10 years.
Yeah. I mean, it's another excellent point. Just if we provide these tools in an effective way, it's effectively impossible to imagine what others will achieve with them, right? Like your point of the iPad is spot on. I mean, just even the iPhone, right? When it first came out, well, I guess there was no SDK when it first came out, but at the point that it was decided to enable app development, just the explosion of capabilities, some of which were absolutely ridiculous, right? I think there's some millionaires that made a flashlight. Now it's just on the home screen.
Yep.
But
the I Am Rich app.
Yeah, exactly. But soon after, right? That soon after we got over that sort of curve, that initial step in the curve of just let's experiment to, oh my, look at all these tools I have. Like I can get access to location and contacts and talk to other people and just, I mean, I'm sure there are many, many things that had never been conceived that are now part of everyday life, which is, it's a really cool way to think about this space. So now that we've decided that all software developers are going to have to understand ML and will be using it in the tools they're building or the capabilities they're building, I want to go back to the analogy a little bit, and I'm curious about kind of managing, right? So you're in the business of building pipelines and helping folks get models out into production environment. Once you have things out, one of the things you alluded to was drift, which I find really interesting. Is there like an SLO analogy? Like, how do I know that my models are working well and that they're doing what I expected, or something's gone horribly wrong? Is a lot of it the same as what I look for in more traditional software, like SLIs, SLOs, or are there other things that people are specifically looking for?
Usually it's other things. Like obviously you still want your, in a lot of ways you can think of models as like a function as a service kind of a thing. You give it input, goes in a black box, you get some output, and that's really all you know. So you want to watch the, like success and failure rates for that kind of stuff, especially, for us as a platform for running models. We want to make sure that, if models are, returning errors more often than successes, then like you want to alert somebody's like, hey, something's probably going on. But remember that fundamentally at the end of the day, models are just really, really heavy on more math than I know. And so most models have some fairly rigorous testing methods for how well the model performs based on the training data set. So, typically when you're training a model, you'll compile your list of or your data that you want to train it on for like images. Let's take image classification, for example. So you'd have a set of images along with their classification that a human went through and marked up. And then you use that training data set to teach the model how to arrive at that conclusion when presented with an image that looks like that. And if your data set's big enough, it can get really, really good at that. But normally you take like 20% of that training data set and you hold it to the side and don't use it for training, but instead you use it for testing and verification as it comes out. So, what you're doing is the model was taught, when you see this picture, that's a cat. That's a hot dog. That's an alien spaceship, and so it knows that because it saw those images. So the useful part is then when it sees something it hasn't seen before, does it give you the right answer? So we keep a certain amount of training data back that we can use for testing, and then there's again more math that goes into computing different scores, and it's different for the different kinds of models. So like our product, for example, for the details for every model, we list what all those performance metrics are. Don't ask me to explain what these mean. You can look at our documentation. We explain it all, but things like precision and accuracy. Natural language models have something called an F1 score. Again, I don't know what it means, but there's math involved. So there's actually a fairly rigorous process. And you can also use that to help determine when you need to retrain your model as well. When your production data starts to not match what your training data was, then okay, so maybe something needs to get fixed up.
Got it. Well, Yeah, I don't know what most of those things mean either, but I'm super interested. Like I get it. I get the notion that there's, specific measures of what's going to succeed in a particular a model or type of algorithm, and being able to map that and measure against it is as important, if not more important than, did I get a 500 or was there high latency on this request? Really fast, incorrect responses is not necessarily something everyone strives for.
Right.
So one of the things that I always love to talk about is failure, because ultimately, if you're moving fast and trying to be innovative, every once in a while things go wrong. Do you have any interesting like failure anecdotes from models in particular, where people thought they were doing the right thing and they sort of went sideways? I have to imagine this early in this space that's a thing that we're seeing.
Well, I don't know about models in particular, but if you read the news, it's fairly well known that bias in models is become a really important topic. Where you have images that classify people, largely trained on white males and are less good at non-white males, and that being a real problem. That sort of perpetuates some of the darker aspects of our societal history, which needs to get fixed. And so so we certainly with all of our models and with all the documentation that comes with our models, we want to be as transparent as possible about the training data set that was used and any known or suspected biases that might be in there. So that's one of the biggest ways that models can sort of hilariously fail, or not hilariously fail in that case, is just if you train something to only find one type of thing and then ask it to find something that's different, it's not going to do as good of a job, and that can have consequences. So that's one. On a more sort of upbeat note, we've had a few cases where someone had we had a model that would what was it? It would count. It was an aerial building detection model that would take satellite photos, and it would map out all of the rooftops, and then you could use that to compute the square footage of the roofs in an area. So we had a company use this for example, figuring out what their total volume of solar panel deployment could be within a particular city, just from satellite photos. But somebody at that company thought I wonder how many, what the square footage of rooftops in North America is. And so they just ran a script that looped through all, 4 petabytes of, of data, and, locked everything up for a while. So, so in some cases you make something too easy to use, and then there's always going to be that one guy who is just let's count all the cars in China,
Yeah, well, not only logging everything up, but I have to imagine that came, depending on how your stuff is deployed, with a really large AWS usage bill at the end of the month or something like that. It's wait a second, what were we doing over here?
Yeah, I'll just say auto scaling limits, really important.
Yes.
Quotas,
cost controls,
really important.
Yeah.
API rate limiting, really important. And we'll just leave it at that.
In every facet, extremely valuable. Right on. Well, I think that your point on bias in there is really important. I would want people to think on that one. And models or no, in everything that we're building, certainly paying attention to how different folks are going to interact, what kinds of biases might be built into our systems is always an interesting problem. So is there a particularly interesting, as because you sit in so much of this and see so much of this going by, is there a particularly interesting application that you've seen of ML recently that maybe is opening up the space, a new space that you didn't think we were going to be able to solve for, or where there's a lot of activity happening that's really doing something new and novel?
Well, as I said before, I'm sort of excited to see what people are going to do when they are able to get their hands on powerful AI that they've never really had access to before. And we're just now starting to see this. I mean, you have companies like Modzy, that are making this available. A lot of the major cloud providers are making it really easy for you to train and deploy your own models. And with tools like like PyTorch and TensorFlow and some of those sorts of things, becoming open source and freely available and more accessible to developers, we're seeing all sorts of new and innovative things going on. And so you don't have to like go out and spend $100,000 on a bunch of GPUs and rack them somewhere and figure out how to power and cool them and all that kind of fun stuff. Mm-hmm. You can just call an API, feed it some data, get an answer back, and then do something useful with it, which I think is a really empowering inflection point for this industry. So I'm curious to see what people are going to do with the AI that already exists, that's been out there, but just not widely accessible. The other thing I'm interested in is, as we, at Modzy, we're focused a lot on drift. We're also focused a lot on explainability. When you run a model, how do you communicate to a human how that model arrived at its conclusion, which can become very important with things like, models that, give a thumbs up or thumbs down for opening a line of credit based on your credit history or something like that. If you get denied and you get sued or taken to court, you need to provide an answer for why that came down. So there's a lot of research going in there, and we in particular have been doing a lot of that research, and with the with the goal of having transparency for models. It's great that it gives you an answer, but you want to trust that answer, and the one way you trust it is how it did it, and you can see it's like, oh yeah, these pixels in this image were the face of the dog, and that's why I said it was a dog. It's like, okay, well, I can trust that result. Beyond that, like I said, I'm not a data scientist, but I know that there's like really interesting stuff going on with unsupervised learning. So I'm sure we've all seen the demo on YouTube of a model that teaches itself how to drive around a track by running into things, and then it goes and it tries that, and then and eventually it's able to race around the track in sort of an optimal thing, and it did that without any training at all. So no input data, it just ran and figured it out. And so that kind of stuff is just really interesting to see what kinds of things that aren't even like in our minds today are going to be made possible with technologies like that.
Well, that's the one where my sci-fi fears take over, right? And the machines just take over.
As long as we don't let those models learn based on YouTube comments, I think we'll be fine.
Yeah, fair enough. So, well, that's an interesting one because, you're saying that explainability, sort of traceability of how the model got into production, the sort of the security and compliance implications of that, all those things, I have to imagine get very different or very difficult in a world of unsupervised learning, right? Where the model is basically training itself. And so being able to go back and, I don't know, is that logged? Does it, when we do stuff like this, record basically, now I'm taking this information, now I'm a machine, but like I'm taking this information and use it to build this decision?
Yeah, well, and this is some of the research that's going on, right? Is how do we get it to, how do we not only get a model to give the right answer, give it quickly, give it cost effectively, so you don't have to spend $100,000 on GPUs in order to run it. Run it on smaller devices. Edge computing is becoming a big thing, with AI, because you've got all these smart cameras and these smart devices and IoT and stuff. And rather than shipping all that data to some data center for processing, what if you could just do it right there, which is like really important for autonomous vehicles. For example, you want the car to make the decision in the car, not have to Wi-Fi that or 5G that data somewhere, which takes time and, could be critical if it needs to swerve, for example.
More than time, that's always going to happen when you lose your signal, right? Yep. When there's no network connection is gonna be the moment where a critical decision needs to get made. Yeah. Like that should definitely be.
Yeah. So you want all those things, but you also want it. But because we're humans and we're distrustful and we don't want to turn it over to the machines. We all saw that movie. We know how it ends. Not so well for us in most cases. We want to have some assurance that we can go back and say like, hey, is this model actually doing what it's supposed to be doing? And can we verify that? I mentioned earlier, medical models, super important. You don't want to miss something. because if you miss something, that has consequences for that person. And so you not only want the answer, but you want to have some way of verifying that you can trust that answer. And so, so with all models in general, the goal is to eventually get there. And some models are easier than others, but
Yeah.
the work
Yeah, it
continues.
makes it. Well, I mean, my mind is blown. There's like so much to learn and think about, and I think that on the one hand, the analogy, it's not even really an analogy. I mean, you said many times models just software, right? So the natural connection to thinking about more typical software delivery, let's say, makes it easy to connect to, but then going all the way out to unsupervised learning and sort of how we think about, building interesting product capabilities in a world where I'll say they start to build themselves. I mean, I'm not necessarily talking about buttons and features, but that concept, right, where it's able to evolve, and then how do we guide that? How do we bring our own creativity? Like, I think it's an interesting thing to think about as we all project into the future. How do we deliver software effectively and ultimately, as you said, continue to deliver great capabilities for our customers? And how is software involved? How are models involved? How much of that can they, can build on top of itself while we go do more interesting things even on top of that?
Yep.
Awesome. Anything else in terms of, I mean, it's a very, it's funny. I'm thinking of it as sci-fi, and for you, it's like every day. But is there anything else that you're seeing as a trend in this space that you think is really interesting or fascinating that you're paying attention to?
This space is still really early. We've seen some players, we've seen some products, but there's still very much this feeling like, not only is the best yet to come, there's just a lot of mind-blowing awesomeness that's yet to come. I think we at Modzy, and I think anyone in this industry sort of feels like, we're just getting started. And, as I mentioned before, sort of step one is just, I got a model, I built it. Now, how do I use it? But that problem is going to get solved pretty quickly here. We think we've got a pretty good solution for that. But it's following the maturity of that process. So in a lot of ways, we're going through a similar thing that DevOps has done over the last 10, 15 years. It's just like, great, I got a program. How do I run it? Well, SSH into a server and, blah, blah, blah. And now we're talking about continuous delivery and 10,000 releases a day and, stuff like that. Because it comes to a level of maturity. And I think AI and machine learning are going to go through the same kind of process here. It's going to have some, a few differences because it is just software, but it's a little bit different kind of software, and there are different things you need to key on. But I think we're going to see a similar kind of revolution. Commodity hardware is getting more affordable. GPUs are getting more powerful. FPGAs and ASICs and just acceleration hardware in general becoming more available. I mean, shoot, we've got one of our engineers has a Raspberry Pi cluster that he runs models on. So
that's awesome. Well, I think what you're describing, I think the analogy is really, really solid in terms of DevOps, like creating a really straightforward pipeline to be able to get the feedback allows us to all fail faster and find the interesting ideas faster, right? So I don't know when this was, but a couple of years ago, I remember being asked for predictions. It's like one of these things that we do in the industry is try to guess what's going to happen next year, and saying, I think ML is going to hit kind of peak hype cycle. We'll be trying to apply it to everything, but a bunch of those things will be nonsense. But what will happen is we'll discover a couple really interesting things, and those will be cool. I can't tell you what those are going to be. Like, you can make that prediction about anything, anytime, and you'll probably be right. But I think that's where we're hitting, is that stride of like that fast iteration, fast feedback that we love. I'll call it on the DevOps side. I'm just trying to keep the analogy. That's allowing that rapid iteration, exploration of these different domains and saying, oh, wait, this is cool. We can apply this here. Or it's really cheap to try it and fail and go, okay, bad idea. Let's go over here and try something else, which fosters so much innovation. Awesome. Well, very cool. I'm very excited to spend some time with you, Nathan. I learned a ton. I think that a like I said, I feel comfort in the proximity and then a little terrified by the sci-fi view of all this. But I think there's some really interesting things. I think for folks that are listening, great opportunity to go explore what's possible. You know, ML isn't some other field out there doing stuff, but a tool that you can put in your toolkit as you build products for your customers and think about, hey, how can I extend this and how can I maybe give them greater value faster? So thanks so much for joining me today. For everybody that's listening, thanks for tuning in. If you like what we're talking about, subscribe at your favorite podcast provider. And if you want us to talk to someone in particular or talk about something in particular, hit us up on Twitter at CircleCI. Nathan, thanks again for joining me. It's been a real pleasure.
My pleasure.